Design stories about the DC26 vacuum cleaner and the AM01 fan. I think these days people sometimes think design just means styling, but for us design is not styling, it's about making products better by design. For that you definitely need engineering knowledge. We'll talk a bit about this DC26. And DC26 was a vacuum cleaner we designed specifically for the Japanese market. We already sold some vacuum cleaners in Japan, but we wanted to make one which was much more suited for the way Japanese people clean. So to start with, one of our UK engineers came to live in Japan for 2 years to experience the Japanese market. So we found out various things, but one of the main things we found out from the Japanese cleaning habits was people tended to clean little and often instead of one big clean at the end of the week. And also that people needed a compact product to fit into their compact lifestyles, and also that cleanliness and hygiene was extremely important. This generated our design spec for DC26, a compact cleaner for regular cleaning, but still having great pickup performance and hygiene. And the first part of the design process was just as simple as sketching. So here's an early sketch of DC26. And basically this just shows the basic position of the main components of the machine, the motor, the filter, and how many cyclones we were thinking of putting into it. Extremely basic, but it gives us a general idea of how the air will flow through the product in 2 dimensions. And then that was very quickly followed by card modelling. So we use card and modelling foam and bits of old vacuum cleaners to make these. So again, this just helps us understand the basic structure of the machine and where we think the air is going to flow through it, but this time in 3 dimensions instead of 2. So again, that's a very quick process, and after that we move into CAD modelling and rapid prototyping. So in Dyson we believe that making prototypes as early as possible is really important. So rapid prototyping helps us get into 3D plastic prototypes very quickly. Well, we use a couple of different processes in Dyson to make rapid prototyping. One is called SLS, or selective laser sintering. So another process we use, which you also might have, is called 3D printing. Now these plastic parts are very realistic, and we can actually screw them together and put motors in them and make a complete working prototype from them. It's really good because it means you can sit around a table and discuss them and feel what the parts are actually going to look like and feel like. So after the first prototypes are made, we can test them and do performance testing and sound testing and all sorts of different tests on it. And then we can check the results and change the CAD slightly, make more plastic models and retest again. Right, and because these are working prototypes, we can take them into customers' homes as well and test them with users. So when we were developing DC26, we brought prototypes to Japan before we sold it. It's a bit more CAD. And customers tested them in their homes just to see how they worked and what they thought about them. So once we were confident we had a good enough product, we ordered the expensive injection moulding tools and prepared the product for manufacture. So I think there are a couple of key points it would be really useful to take away from that DC26 design story. So firstly, thinking about the cyclonic vacuum cleaner invention, finding solutions to common everyday frustrations is a great way to find new products. And you can find these frustrations in your own life experience, but you've got a much better resource if you look at other people's life experiences and talk to them and watch them. For example, talking to elderly people or people trying to travel around with kids, etc., who've had experiences that you may not have had. So basically, if you can design a product which solves a frustration that lots of people have, hopefully lots of people will want to buy it. And then a final point is creating 3D prototypes at as early a stage as possible really helps accelerate the design process and limits any risk in the future because you find out what's good and bad about your product very early on. This product is very different from our vacuum cleaners, and instead of starting with a frustration, it started by using an existing technology in a new way. So basically the design of the electric fan hadn't changed much in the last, well, however long, 100 or 200 years. The concept for the air multiplier fan was actually born from another product we were developing called the Airblade hand dryer. This product works by blowing a high pressure thin film of air across your hands to wipe water off your hands after you've washed them. What we realised was this could be used to make a fan which accelerated the amount of air that was used, so it blew out more air than it sucked in. And once we knew we had a product that was basically going to work, we took it onto the detailed design phase. And this was basically trying out different motors and different fans in the base and different sizes of apertures on the ring until we had the balance which gave us the best acceleration of air. It was safer and it didn't need a big mesh metal guard on it, so it took up less space in your house. So another way to develop new concepts and products is to find a new way to use an existing technology. This means you need to have knowledge of various technologies, but even if you can't know about all technologies, you can talk to other people who work in different specialities and read magazines, etc. At AMO1, it was only when we made the first product that we realised the key benefits of being very easy to clean and being very stable. So sometimes it's only when you make your first prototypes that you realise the good points of your design.